Alright, this is part 2, Unit 9b, looking at linear functions, linear modeling. And this one, we are using the rate of change rule and just trying to determine the outcome of these questions using that rule. So we have a 1 degree change, increase or decrease, on the Celsius temperature scale is equivalent to a 9/5 degree change on the Fahrenheit temperature scale. And so if we kind of break that down, then we would, oops, don't want the highlighter. We would say that 9/5 degree Fahrenheit is basically 1 degree Celsius. So that's kind of our unit fraction that we're going to be using here, or our rate of change. And so again, 9/5 degrees Fahrenheit for every 1 degree Celsius rate of change that we have. And then we want to know, how does Fahrenheit temperature increase if the Celsius increases by 5 degrees. So again, this is our rate of change here. So if it increases by 5 degrees, so we take our rate of change, which is 9/5 degrees Fahrenheit over 1 degree Celsius, and we're going to multiply that by an increase of 5 degrees Celsius. Notice our units, degrees Celsius, will cancel. And you get 9/5 times 5, which is the same as 9 degrees Fahrenheit. So an increase of 5 degrees Celsius will result in or be equivalent to 9 degrees increase Fahrenheit. And then what about if we are increasing or decreasing by 25 degrees? Again, we're going to use that same rate of change, 9/5 degrees Fahrenheit for every 1 degree Celsius, times it by 25 degrees Celsius. And if I multiply those out, see the 5s are going to reduce here. So, oops, 9, not 4. Degrees Celsius is going to cancel. Wow, where am I getting ahead of myself? Sorry. The answer is 45, and I got all kinds of things running through my brain, but that will reduce to 5. So the 9/5 times 25 is the same as 9 times 5, which is 45 degrees Fahrenheit. So as we look at the change, and this is going to be a decrease, sorry about that, and this one was an increase. So once we have that rate of change, and we know how much in this case we're using degrees Celsius as an independent variable and Fahrenheit as a dependent variable, we can quickly figure out how one changes with respect to the other. Okay, now when we look at the general formula for a linear function, a lot of times a lot of people are very comfortable with y equals mx plus b, where m is your slope, b is your y-intercept, and this is very commonly used. These are straight line graphs. So for example, like y equals 4x minus 4 has a slope of 4, a y-intercept of -4, and that y-intercept tells you where you cross your y-axis on the graph. Now when we're looking at the general formula for a linear function, it's going to be the same. Our dependent variable, which is usually represented by y, equals our initial value, which is that y-intercept, plus the rate of change times the independent variable. So hopefully you can see here, this is like a y equals, and then b plus m times x, or y equals mx plus b. So when we talk about dependent variable, we're usually talking about y. We're talking about independent, we're talking about x. We're talking about the y-intercept, that's our initial value. So sometimes we use those terms interchangeably, and then we'll go from there. Now you can also find a linear function when you have 2 data points, because if I've got 1 point, then there's actually an infinite amount of lines that you can draw going through that 1 point. However, the moment you add a second point, there's only one line segment that will go line that will go through both of those points. So if you have 2 points, you have sufficient to create a linear function. And you have to make sure though that what you're going to create your linear function for, what it's going to represent, is reasonable. So here's kind of the way you're going to create this. So you have your x as your independent, your y as your dependent variable. You're going to find your rate of change, so change in y over change in x, or your slope in other words. You substitute in the slope. So you substitute in slope for m. And then you also substitute in x and y into your function, and that will allow you to solve for your y-intercept of b. And then you'll have your slope, and you'll have that y-intercept, or again, that you have the rate of change in your initial value, and that'll take care of the unknowns in your equation. Again, they're going to follow this y equals mx plus b. Just remember that y is referring to our dependent variable, m is our rate of change, x is our independent variable, and b is our initial value. So now let's just end with a handful of problems here dealing with linear functions. So each of these can be modeled using linear functions. We're going to write that equation and use it to answer the question that is given. We want to be clearly identifying our independent and dependent variables, and then discuss whether or not the linear model is reasonable for the situation that we're given. So the first one we have, the cost of leasing a car is $1,000 for the down payment and a processing fee. Excuse me, plus down payment processing fee plus $360 per month. So $1,000 down, $360 per month. For how many months can you lease the car if you have $3,680? So in this case, we've got our dependent variable, which is going to be kind of the amount that you paid. That's going to equal the initial amount, which is $1,000, plus the rate of change. Well, that's $360 per month times the number of months. So let's just say times months here. Yeah, and that's going to be our model. So the dependent variable is going to be the amount paid. And then our independent variable is going to be time. In this case, it's time in months. And we want to know if we have $3,680, how many months can we afford this car? So the amount we're paying is $3,680. When does that equal? 1,000 plus 360, I'll say times m months. So now we just have a basic equation to solve here. So subtracting 1,000, I'm going to jump over here. So 3680 subtract 1,000 is 2680. That equals 360 times m. Then I'm going to divide by 360 to solve my equation. And those cancel out, so I get m to be approximately, on this one, 7.4 repeated. And so you have 7 full months, and then the 0.4 is a fraction. So in this one, you're going to have 7 full months that you're able to pay for it and to lease out this car. Is this reasonable? Very reasonable, because monthly payments on cars usually do not change. A down payment is usually a fixed amount that's agreed upon between buyer and seller. So this is a very reasonable model to be used in this setting. Okay, next we're going to look at you can rent time on computers at the local copy center for a $10 setup charge and an initial $2 for every 5 minutes. How much time can you rent for $25? Now the first thing we need to look at is our rate of change, because our rate of change is $2 for every 5 minutes. So that's going to be 2/5 dollars per minute, or $0.4 per minute. So we have to make sure that we get that rate of change down into, per 1 unit time. So if it's $2 for every 5, then that's 40 cents for every single minute. So that's our rate of change. The $10 setup, that's an initial cost that they're going to charge you, whether you're in there for 5 minutes or 5 hours. And so then we want to find out how much can you rent. So the rent is going to be the starting amount of $10 plus 0.4 or 40 cents times the number of minutes here. So this would be our model that we have. So rent is our dependent variable, minutes or time is our independent variable. So if we want $25, or we have $25, so then we would say that for our dependent variable, I've got $25, and how much time can I use for that? So I'd say 25 equals 10 plus 40 cents times the number of minutes. And then I would just start solving my equation. So subtract 10, I'll get 15 equals 0.4 m. And then divide by 0.4, and you'll get m equals 37.5, and our time here is minutes. So you get 37.5 minutes for $25 that you'd be able to rent out this computer at this local copy center. Now, is this model reasonable? It's reasonable, except there's one little thing, and it would be dependent upon the place. When it's $2 for every 5 minutes, a lot of times what will happen is these companies, when they have it allocated in those time frames, they'll say instead of 40 cents per minute, it's $2 for every 5 minutes. So once you hit 5 minutes, so you get charged $2 for the first 5, and then if you're at like 7 minutes, they're going to charge you $2 again, so it'll be $4, even though you haven't gone all the way up to 10 minutes. So there are some places that charge, once you eclipse 5 minutes, they automatically get the full $2 for every 5 minutes instead of 40 cents per minute. So that's the only place where this could break down a little bit. But still, a linear model here should work out fairly well for us. Okay, we will continue this in a part 3 and end it there. But if you have any questions, do not hesitate to let me know.